I'm here at my home school, the Humanities and Communications Magnet at Lincoln High School, and I'll be your guide on a fantastic trip that my classmates and I took earlier this year. When we first arrived in China, it was like being in another world. We stayed in Beijing, but as a surprise, we were flown to Harbin, China, where we saw a city made entirely of ice. It was awesome.
This particular group, you've been chosen as leaders here at Lincoln.
The World Classroom offers students an opportunity to go outside the classroom and learn about people, cultures, and languages around the world. It offers them the opportunity to actually visit with the native people.
The students themselves were charged with presenting a new technology to China. So what we did was each of the students had a theme of Western culture that they were going to showcase the students to. So the students themselves are actually charged with going over and showing the Chinese how to use this web tool.
The stuff she thinks is important, she put it in order.
In education, very good. Excellent. Very nice.
See, look, it was like this, like, you see. Chinese students naturally try harder than we do because they feel like they have to be the best at everything. Being average is not an option. Many feel that when they're in high school, they have to work hard to get into a good university. If they're accepted, they then have to work harder to graduate in order to have good careers. Working with the Chinese students to do our themes and work on our web pages, we use a ThinkQuest, which is a web page building tool, and we use the Intel thinking tools. And so I was astonished when they got finished with their work, because I'm like, wow, you did that in this little amount of time.
For students traveling abroad for the first time, this is a new experience. They're unaware of what's involved in traveling and the preparation that it takes. Through private funding, through grants, and various other opportunities, we are able to take the students outside the classroom. We feel that it's important to allow all students to participate on the trip, whether or not they have the funds or not. So most of the students put in very little money into the program, but we encourage them to put in time, effort, and work for their position on the trip.
There was one part in Harbin where we had a chance to slide around a frozen lake and then slide down this like toboggan type thing, which the kids kind of enjoyed. And really it's interesting because they get a chance to get out there and just play and be kids.
When we were walking up the wall, it was like, we were in awe. You couldn't believe that you were actually there, that our feet were actually planted on this wall, and it's so historical and it's so amazing. It's like we're really there and we're walking up the wall. I really enjoyed the opportunity to share aspects of my culture and learn about life in China. One of the best ways to experience another culture is to talk to people from other parts of the world and get to know them.
We all have the same goals in mind, and that is to educate our students, expand their minds, and become worldwide leaders in the community. We can do this, and we can extend outside the classroom.
I really consider myself very fortunate for the opportunity to visit China. I saw great and wonderful things, but most importantly, I made new friends. Well, that's it for now. Back to you, Dale and Joanna.
One day in the city of Dallas. 516,000 alarm clocks wake up the city. Millions of cars commute to work, and 2,500 planes take to the sky. One day in the Dallas Independent School District, a masterpiece is perfected. Records are broken. New worlds are explored, and the promise of tomorrow becomes a reality. Think you know DISD? Think again.
What's up, you guys? My name is Daryl, and we're where it all happens behind the scenes of Calculus Live. Thanks for tuning in for today's show. But before we get started, we just want to cover a few ground rules. So let's head over to my man Ivan for more.
Okay, good luck on your problem. Okay, ground rules. Let's see. You have to call in. Pick up the phone, give us a dial, give us a ring. I mean, we really want to hear from you. The number to call is 972-925-3123. Take a picture, write it down, just give us a call.
Number 2, when you do call in, step away from the television. It really hurts our ears and it sends off a really bad tone. See what I mean? So, when you call in, step away from the television. I thank you, our hosts thank you, and our ears definitely thank you. And another thing, when calling into the show, please do not use cell phones. Cell phones do not work too well with our audio system here in the studio. They give off a really bad signal and we have a hard time hearing what you're saying. So remember, no cell phones. Another thing that we want all of you out there watching to know is that you could be on TV. That's right, your face could be on the tube. Send us a picture, whether it be an individual photo or a photo of your entire class. We'd love to see you, and so would everyone else out there watching. Either mail it to us through interdepartmental mail at DISD Box 379 or drop us a line at calculuslive@dallasisd.org. Okay, well, it seems like it's just about time for the show to get started, so I have to say goodbye for now. But don't forget to call in for your chance to win all sorts of cool prizes. So get set for our all-new edition of Calculus Live.
Welcome to Calculus Live. I'm your host, June Harmon. Call in and we'll work calculus problems together. Let's meet my student assistant for today.
Hi, I'm Asia Okra. I am in Ms. Mack's class at Spruce High School. I plan to attend Texas A&M University of Commerce.
Asia, why don't you remind the students about some of those rules?
Avoid feedback by using the telephone in the classroom. Cell phones do not work. Turn down the set a little when you're on the air and sit back and relax.
We are counting down until the AP Calculus exam on May 3rd. Asia, how many days do you have?
Get ready to rumble!
There are 13 days.
We should get right to work. Asia, who's our first caller?
Our first caller is David from Molina High School.
Hey, David. David?
Hello?
David. Hi, David.
Hello?
How are you?
I'm good.
Is this your first time to call?
No.
No? Oh, well, good. I'm glad you called before. I got your picture ready.
Okay.
Here we go. You're number 4, right?
Yeah.
Excellent.
It's a bad picture.
That's a great picture. So how's everybody doing in calculus at Molina?
It's pretty cool.
Pretty cool?
Yeah.
All right. I got a problem for you. You ready?
Yeah.
Are you coming to the prep session Friday night or Saturday morning?
Friday night.
Friday night. Good. I'll see you. I'm going to be there all Friday night and then part of Saturday morning. So I'll look for you. All right. Natural log of x plus 1 times x minus 3, and I want a derivative.
Okay.
What do you want to do?
Split them.
All right. Tell me how to split them.
Natural log x plus 1 plus natural log of x minus 3.
Why is that a good idea? It is a great idea.
It's easier to take a derivative.
That's right. Keep going. Oh, I said y prime. I need to say that's y. Now y prime is?
1 over natural log. I mean, my bad. X plus 1.
Excellent. Good recovery.
Plus 1 over x minus 3.
That's right. And you know what? I'd stop right there, wouldn't you?
I would.
Unless they force you to do something else. Now, they could force you if they put a multiple choice question, right?
Yeah.
But this is a great answer. You did a very good job. Listen, thank you, and you guys call back. Asia, who's our next caller?
Our next caller is Ben from Bryan Adams.
Hi, Hi, Ben.
Hi.
How's everybody at Bryan Adams?
We are excellent.
Excellent. Have you been having any testing?
Oh, too much.
Too much, haven't we all? Are you just worn out? You didn't have to, did you have to take any?
No.
No, you didn't have to? All right, that's good. I don't always know how old you guys are, if you're in the age that has to take or if you're all through with that. It's nice to be all through, isn't it?
Yes, ma'am.
Okay, here's a function that's got so many words.
Oh, my.
I know. Look, read it and see what you think. I'll read it out loud. Let f be twice differentiable, okay, fine, such that when x is c, here's the news. F is decreasing, concave up, it has an x-intercept.
X-intercept.
I want you to order f, f prime, and f double from least to greatest. You know what I recommend? I recommend you make a sketch.
Yeah.
How you feel about that?
That's good.
All right, let's make a sketch. I'll pick x as c to be right there. Is that okay?
Yes, ma'am.
All right. The function is decreasing, concave up, and has an intercept. What does that mean?
It goes across the x.
That's right. And it's decreasing, so how do I draw that? This
Down.
way or this way?
That way.
Down, and it's concave
Up.
up. So now I've got a picture. I feel better. We're going to compare f, f prime, and f double. What do you know about f of c?
It's 0.
It's 0. Good job. What do you know about f prime?
It's negative.
That's right, because the function's decreasing.
Yeah.
What do you know about f double?
It would be positive.
That's right. So if you need to order from least to greatest, which one's the smallest?
F prime.
Less than? What's
F.
next? F less than
F double prime.
f double, because you've got negative, 0, and positive. This one asks it in words. Sometimes they'll show you the picture and ask you to order it. So good job. You did a great job.
Thank you.
You call back. Ouch. Asia, who's our next caller?
Our next caller is Jessica from Molina.
Hi, Jessica. How are you? Are you number 18?
Yes.
All right. Let me put you up. Let's get your picture shown. How's Molina today?
It's good.
Good?
Yeah.
Y'all been testing over there?
Yeah, we're testing. Actually, we have a field trip to seniors.
Are you? Where'd you get to go?
Oh, we went to the Sixth Floor Museum.
Did you really? I've never been there. I've been thinking about going.
Yeah, it's really great.
It sounds like it'd be really good. Well, have fun.
Alrighty then.
Alrighty then. I agree. All right, here we go. I better hurry because they left it on the problem and I left it in blank space. Oh, well, now we're ready.
Okay.
Here we go. Back to the problem. The average value of f of x equals x cubed over the interval a to b. Now, that kind of worried me. I wasn't sure I knew what to do. Do you know what to do to that?
Yes.
Okay, tell me what to do.
We need to find the average value.
Okay. Help me out.
It's 1 over b minus a, integrate a to b of the function, which is x to the cube.
Perfect. Keep going.
Bump it. We have to bump it up. And
All right. Tell me what to write.
x to the 4 over 4. Run it from a to b.
Keep going.
And then we have to 1 over b minus a, and then we have to plug b, so that would be b to the 4 over 4 minus a to the 4 over 4.
You know what? That is a beautiful job. You know, you could rearrange it some. You could say b to the 4th minus a to the 4th over 4b minus a. You could do stuff like that. But you did a beautiful job. You did exactly what it asked you to do. You had the average value. And had you done one before where you just plugged in letters? See, that's a little different, isn't it?
Yes.
Sometimes they give us numbers. But you did a great job. That looks wonderful.
Thank you.
We might could do more with it, but I'm happy with that. What do you think?
Okay.
I'm happy. Hey, thank you for calling in. You guys call back, okay? Bye-bye. Who's our next caller, Asia?
I think we should let our next caller introduce themselves.
All right, a mystery caller. I love a mystery caller. We got a mystery caller? Hi. Who's there?
Hi, it's Maggie.
It's Maggie from?
Yes.
From where?
I can hear you. Hold on.
Where are you from, Maggie?
Adamson.
I knew that. Maggie from Adamson. Put Maggie down so we'll have her in the running for those prizes. How's everybody at Adamson, Maggie?
Woohoo!
How's everybody at I can't talk. Adamson doing?
They're fine.
They're fine? Good.
This is a plug.
I like your new room. That's a really nice place, isn't it?
Yes, it is.
All right, here we go. I got a good problem for you, Maggie. This is f prime of x. Maggie, I'm going to write that 3 times. So we don't forget. We're looking at what?
F prime.
F prime. How many local maximums, maxima is plural, how many local maximums does f of x have? If this is f prime, we're looking for relative max. Sometimes they call them local. Relative max on the function f of x. Well, you know, relative max and mins occur where?
At the x-axis?
That's right, where the first derivative is 0, or it could be undefined, but we don't have anything about that right now. So we've got zeros here. That's at -3. It's a little hard to see. And 0 here, and 0 here. Are any of those relative max for the function?
Yes.
Which one?
At 0.
At x equals 0, the function has a relative max. Tell me why? Because the first derivative changes sign from
positive to negative.
Perfect. These other two are relative whats?
Minimum.
Relative min. Good job. You analyzed it, you remembered what you're looking at, and there you go. All right.
Yeah, baby.
Thank you for calling in. You guys call back.
All right.
Bye-bye.
Bye.
Who's our next caller, Asia?
Our next caller is Rosemary from Molina.
Hey, Rosemary. Hey, Rosemary. Which test are you going to take? Friday night or Saturday?
Friday night.
Excellent. I'll look for you there. I'm going to be there Friday night. We're all going to eat pizza, right?
Yes.
Got your picture, Rosemary? Let's see. Here we go. Excellent.
Yay.
All right. Let's see what we got here. Let's see what kind of problem we want to give. Oh, here's a good one that a lot of people miss, but I don't think you're going to miss it because you get all these right. I'm not sure. Let me get where you can see it. Okay. Integral from 0 to x squared cos of t cubed dt, and I want the derivative of that.
Okay.
What do you do?
FTC2.
There you go, FTC2. Tell me what that stands for.
The second fundamental theorem of calculus.
Perfect. I love that. I like FTC2. Okay, go for it.
Okay. Cosine of x squared cubed. Perfect. And times the derivative, so 2x.
Excellent. You know what? That is beautiful. What could they call x squared cubed?
X is 6.
That's right. They could call it. And if they did, that's fine. You'd be able to find it because you know. That is perfect. A lot of students forget the chain out, don't they?
Yes.
Don't forget the chain out and you'll be better than the rest of the nation, right?
Yeah.
Possibly the world. Yeah, the whole world takes this test, so you'll be better than the rest of the world. Hey, thank you for calling in. You guys call back.
Okay.
Who's our next caller?
Our next caller is Twan from Bryan Adams.
Hey, Twan.
Hi, how are you?
I'm fine. How are you doing?
I'm fine, thanks.
Good. I've got a problem here for you. It's a multi-part problem, but I'll give you one of the parts. How's that?
Okay.
All right. A function, y equals f of x, satisfies the differential equation dy dx equals x squared minus 1 over y. Initial condition f of 2 is 1. I want you to find the second derivative at 2. The second derivative at 2.
What's
Do
that?
you know what to do to get the second derivative?
Derive it?
That's right. Take another derivative. I'll start you off, d squared y over dx squared, and I'll make you do the hard part. Go for it.
So it's going to be x squared minus 1 dy dx.
Are you sure? Quotient rule? Tell me what your quotient rule is, okay?
Is the quotient rule?
Tell me what you use for quotient rule.
B times the derivative of a.
B times derivative A
Minus a.
Minus A
Times derivative of b.
times derivative of B over
B squared.
B squared. So you just told me to write A. Is that what you meant?
Yes.
You meant...
No.
Right, there you go. It's been a long week, hasn't it? Let's try again. Go for it.
Okay. Y
There you go.
Minus 2x, times 2x.
Perfect.
Minus x squared minus 1 dy over dx.
Good.
Over y squared.
Over y squared. Now let's see if we've got any plug-ins. There's an x and there's a y. Could you use those and plug in?
Yes, ma'am.
Okay, let's do it. Tell me what you get.
2.
Oh, you're way
2.
faster than me. 1 times 2 is 2. Good. Take away.
Minus. Hold on. 4.
4.
No. I think I missed one on the beginning one. Okay, 1.
Say it again. I think you're doing fine. 4 take away 1.
4. I think the first part should be 4 because 2 plus to the x and times 1.
Oh, thank you. Thank you for catching that. I was letting that slip by.
Okay.
Good job. Okay.
Over 1.
4 take away over 1. And we've got that dy dx. Could we go up here and evaluate it and just plug it in? All right, go up here and do that for me. 2 squared is?
4.
Take away 1 is?
3
over
1.
So it's a 3. Great. Okay, we're in business. Keep going. 4 take away what?
4 minus 9 over 1.
And that gives you?
Negative 5.
Yay! Did Ms. Arthur say that was right? Extra round of applause here. Round of applause and a bell. Hey, you did a good job. You got that second derivative. I like the way y'all do the B's and the A's. That's a good way to do it. A's on top, B's on the bottom, right? That's a good job. Thank you for calling. Call back. Who's our next caller?
Our next caller is Christian from Addison.
Hi. Hey, Christian. How are you? Are the Adamson ladies coming Friday night or Saturday morning to take the practice test?
Saturday morning.
Saturday morning. Good.
Yeah, and Friday too.
Say it again. What?
And Friday too.
Oh, some of you Friday and some Saturday?
Yes.
Excellent. I'll be there all Friday night, and I'll be there part of Saturday, so I'll look for you, okay?
Okay.
Wave at me if you see me stumbling by, okay?
Okay.
All right. Do you like differential equation solving? I know you do.
Yes.
You guys had prom already?
No.
When's it coming up?
Next week.
Oh,
Friday.
boy. Oh, boy. So you'll just have a little prom because you'll be working for AP exams, right?
Yes.
So just a tiny bit of prom celebration. Okay, here we go.
Alrighty then.
Alrighty then. A function y equals f of x satisfies, oh, this is that same differential equation we had a while ago. dy dx equals x squared minus 1 over y. F of 2 is 1. I want you to find y equals f of x. It could say solve the differential equation.
Okay, so we're going to do the integral.
That's right, we're going to do the integral. Tell me what to write.
The integral of we're going to separate first.
That's right, we're going to separate first. Tell me what to put.
It's y dy.
Y dy.
Excellent!
X squared minus 1 dx.
Dx. Do you think we could get these sound effects in our ear on the day of the exam? That would help, wouldn't it?
Certainly. Yeah.
You had somebody telling you what a great job you were doing the whole time? Okay, keep going. That's perfect. That's a point right there.
Okay, so it's going to be y squared over 2. Y cubed over 3 minus x plus c.
Beautiful. Now, you want to go ahead and plug in now?
Yes.
Okay, tell me what to write.
1 over 2.
All right, speak a little louder if you can.
Okay.
Thank you.
What's x2, right? So 8 over 3.
8 over 3.
Minus 2 plus c.
Good job. Got to keep going.
Okay. I want to multiply the 8 over 3 minus 2.
Okay.
So I can just do it.
1/2 equals, now tell me again what you want to do. You want to make these both 3's?
Yes.
8 over 3 minus 6 over 3 work?
Yes.
Okay, good. Now,
The
keep
same
going.
thing.
We're making you do a lot of arithmetic on this one.
Okay, 2/3
That's right.
plus c.
Okay, now you want to subtract this one?
Yes.
So we need a common what?
Denominator.
And what'll that be?
Okay, it's going to be 6.
6.
3 minus 4.
And the final answer is, dum-da-da-dum, drum roll, please.
-1/6.
-1/6 is C. Now, I've forgotten what the problem is, haven't you? But I'm going to read.
No, I remember it. We have to rewrite you have to write the
That's right. So let me rewrite it where you can see it, because you can't. I'm off the paper here, aren't I? This is a long problem. Takes 2 pages and I'm running out of room.
Okay.
Okay, so far so good, but what do we need to do to get that final point?
Okay, we're gonna write it as y equals.
Okay, y equals. How are we going to do that?
Multiply by 2.
Okay, y squared equals, I'll do the first one. You do the next one.
2x minus 2. 1/3.
That's right. And you can say 2 over 6 if you want to, but 1/3 might show up on multiple choice.
And then we just get the square root of the whole thing.
All right. Now let me ask you a question, okay? How do we know it's not the negative? What is it that we know it's not the negative?
Because of the point they gave us.
That's right, the point they gave us. Good job, that is brilliant. The point they gave us is a positive, so we know it's the positive square root. We have to watch, though, if it's the negative point, we can get in trouble, can't we?
Yes.
Hey, you know what? Bells all around. Round of applause. We should do the roller coaster. Are you ready? This is worthy of the roller coaster award. Ready? Woo! You'd like to do that with me, wouldn't you?
Yeah.
We'll do the roller coaster award the next time I see you.
Okay.
I have not given the roller coaster award this year. You're the first recipient.
Okay.
Thank
that's
you
good.
so much for calling in.
Okay.
Bye-bye.
Bye.
Who's our next caller?
Our next caller is Sergio from Molina.
We got a picture of you, Sergio?
Sure.
Here we go.
Don't laugh at me.
That wasn't me. Talk to the sound effect guy, okay?
That's when I had my hair.
Oh, yeah? What have you done to your hair since then?
Huh?
What have you done since
I
then?
shaved it.
Did you? Well, then I won't recognize you. So tomorrow, if I see you at Townview, will you say hi and tell me who you are?
Sure.
Okay, because I'll be looking for that picture, right?
Yeah.
All right. Let's see what we've got here in the magic problem box, all right?
Alrighty.
Well, you know, I've got a problem here that's open-ended. Do you mind open-ended problems?
It doesn't matter.
Okay. I've got a function that's continuous over the closed interval and differentiable over the open interval. Given f of 0 is -2 and f of 5 is 3, I want to know some stuff you know to be true. Is that too open for you? Some stuff you know to be true. Now, I'll tell you, I would have a thing I'd want to do first. What would you do first?
Oh, we should do the mean value theorem.
Oh, you know what? That's a great idea. Let's draw a picture.
All right.
At f of 0, you get -2, right?
Yes.
And f of 5,
3.
you get 3. And you said, I believe I'll do the mean value theorem. This is 0, -2, and 5, 3. And you know what? That is a great idea. Tell me what the mean value theorem would say about this problem.
The geometry slope has to equal the calculus slope.
Very good.
Correct.
So,
Boy wonder.
correct. Can you find that for me and tell me what the calculus, what the geometry slope is for this problem? The calculus slope we know is f prime of some c, right?
Yes.
What's the geometry slope?
It's right. Y2 is 3 minus -2.
Good.
And
Good answer.
5 minus 0.
And what would that be?
It's 5 over. It's 1.
It's 1. Good job. So if they said f prime of c is 1, you'd say, well, yeah, mean value theorem. You're exactly right, mean value theorem. Can you think of anything else you know about this function? If you know it starts at -2 and stops up here at 3, what else do you know? What could happen?
It could have an absolute max or absolute min.
It could. It could also have a 0 in here, right? At least one. If you go from down here to up here, you're going to have a 0 somewhere.
Yeah.
So f of x could be 0. That's your intermediate value theorem. You could have a value of -1 and 0 and 1 and 2 and 2.5. All of those intermediate values come into play. How do we know that? The function is continuous and differentiable.
Okay.
Hey, listen, you did a great job. You recognized mean value theorem immediately.
Thank you.
Excellent. Bells all around. Sounds like we have extra bells, don't we? Extra bells in our ears. Who's our next caller, Asia?
Our next caller is Brittany from Townview.
Hey, Brittany, how are you? Brittany? Is Brittany there? Who's there?
Hello?
Hi, who's this?
Minerva.
Hey, Minerva. Minerva
Hello.
from Adamson. We had one we lost, so you can fix that. Minerva from Adamson. Nice to hear from you, Minerva.
Oh, nice to hear from you too.
Thank you. You going to be there Friday night or Saturday?
Saturday morning.
Excellent. I'll be there. I'm going to work the late shift Friday night, so I'll be there Saturday before it's over, okay?
Okay.
Not necessarily at the crack of dawn. Do you know what time you have to be there Saturday?
9.
9. Perfect. Good answer. All right, look at this problem. Let's see what you think. Integral from 0 to 5, absolute value of x minus 2 dx. Do you know what to do to absolute value?
Yeah, I would like to graph it first.
I agree. I do not want to work these without a graph. Tell me what to write.
You start at 2, Nick.
That's right. You start at 2 and you draw your absolute value, correct?
Yes.
So this is 3, 4, 5. Now I'll mark that for you. And this is 0. All right. So now what are you going to do? You got a couple of nice little triangles there.
You're going to find the area?
Okay. How are we going to do that?
1/2 times base times height.
That's right.
No problemo.
And what are the base and the height?
The base is 4.
Say it again.
2.
2. That's correct. And what's the height that goes with that?
0.
When you plug 0 in, you get 2. That's exactly right. Now let's do the other one. What's the base of this one?
3.
And what's the height?
2.
When you plug 5 in, oops, 5 take away 2 is how much?
3.
Good job. What's half of 2 times 2?
4.
That's half of 4, which is?
What's 2?
Good job. What's half of 9?
9.
9 halves are 4.5, right?
Yeah.
What's the final answer?
6.5.
Good job. Hey, that is beautiful. I'm with you. I never do these without drawing a picture and just finding triangles. That's the easy way to go, isn't it? Remember, if you forget what the plug-in is, just plug it in right here. 5 take away 2. Oh, that's got to be 3. Okay? Hey, good job. You did a great job. Hey, let's have a bell for that. Here's our next caller, Asia.
Our next caller is Erica from Molina.
Hey, Erica. Here's your picture. Erica,
That's not me.
What?
That's not me.
It's the wrong Erica. Tell us your number.
I don't know.
Oh, well, we'll find you in a minute. Asia will find you while we start the party.
32.
Huh?
32.
32. I knew you knew your number. All right. I got a limit problem. You know, we have to know limits and derivatives and integrals. This course is easy, right? You just got to know 3 things. Limit, derivative, integral.
Oh, I don't like those.
Oh, these are beautiful. The limit is x goes to infinity. Look for the biggest powered x, top and bottom, okay?
Yes,
Biggest powered x, top and bottom. Circle them.
You divide the coefficients.
That's right. Look at the coefficients. And don't lose this little sign here. What's your answer?
-3/7.
You know what? I think you love this problem. That carries the weight. X to the 5th is huge compared to x, isn't it? As x gets really, really big, we're talking like millions, right?
Yeah.
Like we're talking gymnasiums full of sand here, minus a few sprinkles. Here's your picture. Now did I get the right one? Now do I have the right Erica?
Yes.
Excellent. Which session are you coming to? You going to come Friday night or Saturday morning?
Saturday morning.
Excellent. I'll see you there. You'll be there at 9 a.m.?
Yes, I will.
You will remember to bring a pencil and a graphing calculator?
Yeah, I will.
Yay.
Bell. Bell.
Bell. That's right. Hey, thank you for calling in. You guys call back. Asia, who's our next caller?
Our next caller is Karina from Adamson.
Hey, Karina. How are you?
Fine.
Y'all having good luck getting through today, aren't you?
Yes, we are.
Excellent. I'm glad to hear that. All right, here's a problem for you. Let me get it where you can see it here. All right, I'm ready when we are. There we go. The slope of the tangent line to the graph of y equals tan of 2x at x equals pi over 8. What do you need to know to get the slope of the tangent line?
The derivative.
You need the derivative. Do you know what the derivative is of tan of 2x?
No? Secant squared.
Secant squared of 2x and?
Times 2.
Times 2. Chain, 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 right? Do you hum that in your head? Chain, chain, chain. Don't forget the chain rule. All right, y equals 2 secant squared. 2 times pi over 8 is pi over?
Pi over 4.
Good. All righty. Gee, how are we going to deal with secant? I don't know much about secant. Do you know
Rewrite
anything? Rewrite it to what? I agree.
Yes. Cosine, pi over 4.
And then square. Yeah. How are we going to get cosine? Do you do that hand trick?
Yes.
All right. I will use my hand. Which finger do I use for pi over 4?
The middle finger.
The middle finger. Close it in. Is this cosine or is this cosine?
Above.
Above. Cosine comes before sine. 2 over root 2. Tell me what to say.
The root of 2 over 2.
The root of 2 over 2. So it's 2 over root of 2 over 2 and squared. I love that hand trick. Who taught you that hand trick?
Mr. Bentley.
Mr. Bentley. And you know who taught it to me? Ms. Mack. Do you know Ms. Mack?
Yes.
She taught me the trick. All right. Now, can we clean this up?
Yes.
What do you get?
2 over 4.
Excellent.
I agree. That is excellent.
Okay.
And what do you get?
It's 4.
It's 4. Now, I've forgotten what we just found. Do you know what we just found?
The slope of
the slope. So I'm going to say m is 4, and now I can remember it because I've written it like that. All right. Now, we know x is pi over 8. Do we know y?
No.
No.
You substitute it in.
Okay. Tell me what to write. Y equals tan.
Tangent.
2 times pi over 8. What is that?
Tangent of pi over 4.
And what is the tan of pi over 4? 1. And so we've got x is this, and y is this, and there's our slope. Can we write an equation of a tangent line?
Yes.
We are in business. Go for it.
Excellent.
It's y minus 1 equals 4 times x minus pi over 8.
Hey, that is beautiful. Do you want to mess with that and clean it up?
No.
No, not unless they make you, okay? If they make you on a multiple choice, okay, fine, we'll multiply out. We can do that. But if they don't make us, we're leaving it right there. Hey, you did a beautiful job. Thank you for sharing that problem with us. I look forward to seeing you at the test.
Me too.
Thanks. Who's our next caller, Asia?
Our next caller is Maria from Molina.
Hey, Mario. Hi, Mario.
Hi.
Have y'all had prom yet?
No.
When is it?
May the 6th.
Yay! After the AP exam.
Yes.
Perfect timing. All right. Well, I hope y'all have a great time. Did you see your picture? Has it shown yet? There.
Yeah, it's right there.
There it is. What is that sound? I don't know.
I don't either.
I don't know what that is. It sounds very naturey. Sounds like the great outdoors, right?
Yeah.
All right. Y equals the natural log of the secant of x. And I, of course, want the derivative.
Okay. There's going to be 1. I mean, you have to separate them.
Okay. How am I going to separate those?
No, I mean, the derivative.
That's right. What's the derivative of natural log? It's du over u. So what can you write right now? You know the denominator's got to be
The secant x.
the secant of x. There you go. What's the top got to be?
Tan x.
Secant x, tan x. And what's left when you clean it up?
Tan x.
Perfect. That is beautiful. Remember the natural log, this is u, and you want du over u. And if they throw trig in, that just makes it a little more interesting, right?
Yeah.
The derivative of the trig is a little more interesting than the polynomial, if you like trig, which we all do, right?
Yeah.
All right. Thank you for calling in. You guys call back.
Okay.
Who's our next caller?
Our next caller is Ruth from Addison.
Hey, Ruth. Hi. How are you? How's Mr. Bentley today?
Fine.
Is he worn out from testing?
Yes.
I bet so. Everybody I know is. And teachers are kind of dragging. Now, y'all are behaving extra nice, aren't you? Because you know your teachers are really tired. Yeah? Y'all are always nice, aren't you? All right, here we go. I got a problem for you. You've seen this picture before. I like this picture, so I used it more than once. This is f prime of x. F prime, f prime, f prime. At x equals 1, what does f have? At x equals 1, what does f of x have? I'm looking for a name of a term, you know, what kind of term? You know what I'm thinking about?
It's f of 1 at x equals 1.
At 1, what does f of x have? For example, let me give you some ideas. Over here, f has a relative min. And over here, f has a relative max. And this is a relative min. What's this point?
Poi.
It's a, oh yeah, you got it. Say it again.
A poi.
A poi. A point of inflection. And tell me how you knew that. You're exactly right. Because what?
That's the derivative. And then for the second derivative, changing the slope from positive to negative.
That's right. Changes sign from negative to positive, okay?
Yes.
Now, let me tell you one more thing. If this were a picture on a free response, you'd need to talk about f prime. That's easy to do. F prime is decreasing, then what?
Increasing.
That's right. Be sure and phrase it in terms of the picture you're looking at. I do exactly what you did. I talk about FW in my head, and I even write that down, but then I address the picture. Oh, I know that because F prime, what I'm looking at, is decreasing and then increasing. That'll get you full
We can
credit.
say the slope of f prime changes from positive to negative.
I think you could say that very nicely. The slope of f prime changes from that would work very well. That tells them you're looking at f prime and you're answering about it. Great job. That is perfect. That's what I say.
Okay.
Thank you for calling in. Who's our next caller, Asia?
Our next caller is Raina from Molina.
Hey, Raina, how are you doing?
Hello?
How are you, Raina?
Good.
Let's show your picture.
Okay.
Here's Raina. Very nice. Is everybody in your class good looking, Raina?
Wow.
Most of
That's
them?
pretty heavy.
You know, most calculus students are really good looking, I've found,
Yes.
don't you think?
I know one.
You know one that's good looking? Are you going to name a name? Are you going to name a name or not?
No.
No,
Secret.
okay. You're going to be discreet. All right. All right. Oh, I got one for you. This is, I was puzzling over this one, trying to decide if we want to use this picture one more time, and I think we do. All right, this is f prime. I'm going to write it how many times?
3 times.
Yeah, I want to remember f prime, f prime, f prime. If f of 2, oh wait, now I'm talking about f here. F of 2 is 1. What is f of negative 2? Do you know what kind of problem this is?
Integration?
Yeah, it's integration. Let's set it up. The integral of f prime from what to what?
Negative 2 to 2.
Good. Equals f of what? When I integrate f prime, I get f of
2.
take away.
Negative f of negative 2.
Good job. This is that FTC number 2, isn't it?
Yes.
You've got one ordered pair, you want to know the other, and you know something about the derivative. Okay, let's fill in what we know. F of 2 is 1. I don't know this one. And can I integrate from negative 2 to 2?
Yes.
From negative 2 to 2. That's going to require some geometry, right?
Yes.
Okay, tell me what to write. This is a little trapezoid. I don't know if you can see it well enough. It's got a height of 1, a base of 1, and a base of 2.
They cancel. The 2.
Some of it's going to cancel. You want to go ahead and cancel what cancels? Is that what you're wanting to do?
Yes.
So we could cancel this and cancel this.
Yeah.
Well, that cuts the work down. What have you got left?
Square. Everything.
A 1 by 1 block, which is 1. I'll put down 1. And you've got over here a 1 by 1 triangle, which is?
Negative.
Negative.
Negative
Good.
1.
Good job. And it's 1 by 1, so it's 1/2, isn't it?
Yes.
Equals 1 minus f of negative 2. So far, so good. You're doing a great job. Now, what can I do now?
Cancel.
Cancel what?
Whoa!
Cancel. Say it again.
The one.
That sound effect cut you off there. There you go. So negative 1/2 equals negative f of negative 2.
Cancel the negative.
Good job. And what do you get?
1/2.
1/2.
Yeah.
I love that problem because it looks really hard at first until you realize, oh, it's that fundamental theorem of calculus again, right?
Yes.
You did a great job. We're going to have bells for you. Thanks for calling in. Who's our next caller?
Our next caller is Minerva from Addison.
Hey, Minerva.
Hello.
Hi, how are you doing?
I'm doing fine.
Are y'all having any refreshments?
No.
What? Your teacher expects you to do calculus on an empty stomach?
Yes, he does.
Oh, my goodness. Well, you know what? You're probably going to be better women for it all, right?
Yeah.
Yes. Yes, you are. All right, let me find you a really good problem here. Oh, this is a good one. Are you ready? I've been saving this one for just the right lucky caller. All right, here we go.
Go ahead.
The position, S of t, is cos of pi t minus sine of pi t over the normal interval 0 to 2 pi. What's the acceleration at 1?
We need second derivative.
We need a second derivative. So I'm going to make a note that you're going to go for second derivative. So tell me what to write first.
S prime of t.
S prime of t, that would be velocity, wouldn't it?
Which equals v of t.
Which equals v of t. Good. What is that?
Negative sign.
Negative sign. Pi t okay with you?
Yeah.
And what else?
Times pi.
Times pi. I'm going to make this into pi and make my negative there. How's that? I ran out of room. Okay. Keep going.
Minus pi. Cosine. Pi cosine.
With?
And times pi.
And again, I didn't plan ahead, so I'm going to do that. Hey, that's really good. Negative pi sine of pi t, negative pi cos of pi t. And now you told me you were going to go 2 derivatives, so go 2 derivatives. What's the second derivative?
Negative t.
Right. Acceleration, good. So it's negative
Okay. Cosine.
cosine
Cosine.
with a chain out.
Another pi.
Can I square it?
Yes.
Good. Then what do I get next?
Plus.
Good.
Plus pi squared. Squared.
Right.
Sine of pi t.
Excellent. You are doing a great job. All that's left is to plug in 1 for t.
Okay.
So?
1 for t?
Uh-huh.
Okay, it's negative pi over
Pi squared, cosine of
pi
plus pi squared, sine of pi. Do you know your values for pi?
Yes.
Okay, go for it.
Negative 1.
Negative 1 times negative is
Positive.
pi over 2. Great. What's this one?
0.
0. Pi squared. Who knew, right?
Yes.
You did a wonderful job. I like the way you chained out. I like the way you kept track of your derivatives. Some people confuse these. The derivative of sine is cosine, and I always say the other one's negative, right?
Mm-hmm.
The derivative of sine is cosine. You did a beautiful job. That is worthy of the bell. Thank you very much, Asia. Asia's doing a good bell job. Thank you for calling in. You guys call back. Who's our next caller, Asia?
Our next caller is Princess from Molina.
Hey, Princess. We got your picture?
Yeah.
All right. There you go. Princess, that's very nice. Excellent.
Princess.
Huh?
My name is Princess.
Princess?
Excellent.
Did I say it wrong?
You said Priscilla.
Oh, I'm sorry. I meant Princess because I know that name. See? My daughter's name's Sarah, and that means princess in Hebrew, right?
Yeah.
So I know about Princess. Well, I'll try to get it right the rest of the show, okay?
Okay.
All right, let's see what we got. Which test are you coming to?
Saturday.
Saturday? Excellent. I like Saturday. That's a good day. Let's try this one. Are you ready?
Yeah.
Okay. I've got a piecewise function from -2 to -1 and then -1 to 2. And I want the average value on the interval -2 to 2. Do you know what to do with that? That's a little more complicated.
It's the 1 over b minus a.
1 over b minus a.
Integrate.
Integrate.
From a to b.
No way, dude!
Of the function.
Yeah, so which one are we going to use? We got a choice here.
Oh, I see.
So what do you think?
dude!
Both.
Okay, we're going to use both. And how are we going to do that?
F of x. Put in
This one's only good for here. So -2 to what?
-1.
Excellent. and that's x plus 4 dx. Can I rewrite this so I can get it together a little bit? 1 over 4, integral from negative 2 to negative 1, x plus 4 dx. And now I need to do the other half. I'm just going to write it separately if that's all right with you. Integral from what to what?
you guys. Negative 1 and 2.
Of?
Negative x plus 2.
Dx. That is not too bad, is it? You know, it's kind of long and strung out, but those are pretty easy integrals. Are you ready to hit it?
Sure.
Okay, let's hit it.
It's 1/4 x plus 4 x squared over 2.
Good.
Plus 4x.
With plug-ins?
Run it from negative 2 to negative 1.
Good. We'll come back to that in a minute. Plus?
Plus 1/4 is negative x squared over 2 plus 2x. Run it from negative 2 to negative 1 and 2.
Good. Great. You're doing great. Keep going.
And 1/4 you plug in the negative 1.
Right.
So it's 1 over 2 plus minus.
That's okay. I'll put minus here.
Minus 4.
Take away.
Minus 2 plus, no, 2 minus 8.
8. And I'm going to leave that and then get ready to go through in a minute. Is that okay with you?
Yeah.
Otherwise, I sometimes get those confused, okay? Plus 1/4. And now I'll move it where you can see these plug-ins.
It's 2,
Negative 2 plus
4.
4. Take away.
For negative 1/2 plus minus 2.
Great. That's a toughie, isn't it? I'm going to need more paper. This is a long problem. All right.
To infinity and beyond.
That is right. To infinity and beyond. Okay. We're getting ready to go to infinity. You want to help me clean this up? Let's do 1/2 minus 4 minus what?
Negative 6.
Which is plus 6. How's that look? Let's keep cleaning this one up first.
Okay, the answers are going to come on.
Say it again.
Call the main office. Call the main office.
1/2 plus 2.
Good. We could call that 5/2, couldn't we?
Sure.
1/4 times 5. Now don't let me talk you into anything, okay? And that would be 5 over what?
5 over 8.
I like that. Let's go back now and try the other one, okay? All right. I'm going to rewrite it where you can see it. 1/4, negative 2 plus 4, take away, negative 1/2 minus 2. Okay? Now, can you see that?
Yeah.
Okay. 1/4. Now, how can we clean that up?
2.
2, take away.
Oh, it's plus.
Good. I thought that too at the same time.
1/2.
Let's see. It's 2.5, so how about 5/2 again?
Okay.
Is that okay?
Yeah.
All right, don't let me mess you up. 1/4. Make this 4 plus 5 is 9/2, okay with you?
Yeah.
What does that give you? 9 over?
9 over 8.
Yay, look, they're both 8s. What does that give you?
14/8.
Perfect. You could say 7 over.
7 over 4.
Woo! That was a tough problem. That is deserving of bells and thank you very much.
Bye.
Bye-bye. Thanks for calling in. Who's our next caller?
Our next caller is Maggie from Addison.
Hey, Maggie. How are you?
Fine.
Good. You ready for a problem?
Anyone?
Let's see. No. I'm trying to pick my favorite problem, okay? Let's try this one. Sketch a function that has the following properties. The left Riemann sum is an over approximation, and the right Riemann sum is an under approximation. Do you know what they're talking about?
Increasing function.
All right, I'll draw that and we'll see. Increasing concave up or concave down? Let's just try one of them, okay?
Okay.
Which one do you want to try?
Concave up.
Concave up. Okay. All right, let's draw in just one big old rectangle. The left Riemann is over. Is that true?
No.
No, the left is under and the right is over. Let's try something else. What else would you like to try? We're just going to try until we see.
Concave down.
Concave down. I'm just drawing one big triangle. The left Riemann is over, and the right Riemann, oh, is that right? Is that working?
Yeah. Oh, wait.
I think the left is still little, isn't it?
Oh, yeah.
Let's try something else. What else could we try?
Decreasing concave down.
Okay. Decreasing concave down. I'm going to draw one rectangle. The left is too much, and the right, yay, I think you found it. A decreasing function fit the bill here. The left was too little, and the right, I said it backwards, I'm sorry. The left was too much, but the right was too little. So you found one that matched. All you need to do when they start asking about this is draw one big shape. For example, the trapezoid for this, would it be under or over?
Under.
Under. What about this one? A trapezoid from here to here. Over or under?
Over.
Over. So you could draw one piece of the geometry and you'd know the answer, wouldn't you? Yes. Hey, good job. Thank you for helping with that. I like that. That's kind of a new style question, and we're not always used to that, so you did a good job. Who's our next caller? Thank you for calling.
Our next caller is a mystery. Our next caller is a mystery caller.
We got that mystery caller again? Who is our mystery caller? Have we got a mystery caller out there? You know what? I think I'm going to have to ask Asia a question. Asia, I want to know how your school planned prom. What's the date of prom at your school?
May 5th.
After the AP Calc exam, May the 5th. That's exactly right. So that school knew what they were doing, didn't they? All right, it's time to figure out who the winner is for today. How many callers have we had, Asia?
17.
All right, let me get the calculator set up. 17 callers. Let me get it where it can see. Ms. Brzezinski likes to see it. She wants to know I'm playing fair. 17 callers. Asia, are you ready?
Yes. No.
Call out the winners, please.
Our winner for today is number 8 and number 17.
Who are they?
Sergio from Molina and Maggie from Addison.
Sergio from Molina and Maggie from Adamson. Hey, congratulations to you guys. Thanks to all of you. I hope you will tune in next week. It's our last episode of Calculus Live for this season. Keep studying. Asia and I are wishing you a 5 on the AP Calc exam on May the 3rd. Work hard so that you can celebrate when those results come in July. Bye-bye.
Alright, thanks for tuning in for today's edition of Calculus Live. We enjoyed bringing it to you. And as a quick reminder, don't forget to send in photos of yourself and your class. We'd love to be able to show your face on television. Even mail to us through Interdepartmental Mail at DISD Box 379 or drop us a line at calculuslive@dallasisd.org. For all of us here at Dallas Schools Television, I'm Bill, and join us next week for Calculus Live, same time, same place. See you then.